Hi, this is Mrs. Robertson again. Today we are going to learn about the distributive property, Chapter 6, Lesson 6, page 486. So please open your math books up at this time to page 486. And we're going to learn about the distributive property. Yesterday you learned about the commutative property, where the numbers or variables move around, the associative property, where the parentheses move around, and the identity property, where the number keeps its identity when you add to 1 or multiply by 1. So today, we're going to learn the distributive property. In words, to multiply a sum by a number, multiply each addition by the number outside the parentheses. I refer to this as the grandmother property. The 2 is outside the parentheses. 2 has to multiply 7, 2 times 7, and then 2 has to multiply the 4, 2 times 4. So when I reflect on this, grandmother has to give each of her grandkids a hug. She hugs 7, and she hugs kid number 4, whose name is 4. All right? In algebra, you use variables instead of numbers. A times in parentheses B plus C equals A times B and A times C. So the expressions 3 times 20 plus 15 would be 3 times 20 plus 3 times 15. Show how the distributive property combines addition and multiplication. All right, please go ahead and put the parentheses around 3 times 20 and 3 times 15 in your math book. All right, I think we're going to go down to example 2. We're going to skip example 1 for the moment and go straight to example 2, and then we might go back to example 1 in a little while. In an example 2, the distributive property, use the distributive property to rewrite 2 times x plus 3. Well, it's 2 times x plus 2 times 3. 2 times 3 is 6. So the answer is 2x plus 6. All right, now let's do examples D, E, and F, and then we'll go back up to example 1. So in examples D, E, and F, let's do this together. It's going to be 8 times x plus 8 times 3. 8 times x plus 8 times 3, and that will equal 8x plus 24. That is your final answer. Remember, this is an expression. It's not going to equal an exact amount because we have variables involved here. This one will be 5 times 9 plus 5 times x. 5 times 9 is 45. The answer is 45 plus 5x. I'm going to write these answers on our answer blanks. 8x plus 24. Make sure you are doing this also. 45 plus 5x. You could also write it as 5x plus 45. And letter F will be 2x plus 2 times 3 is 6. I skipped the step of writing 2 times 3 because I feel like you are getting good at this, kids, so we could just go right to 2x plus 6. Don't forget, you have to multiply everything that is in there by the 2. Now, let's go back to A, B, and C and look at example 1. Here, you're doing the same thing with the distributive property, but you're breaking up the fraction 4 1/3. You're taking 9 times 4 plus 9 times a third. 9 times 4 is 36. 9 times 1/3 is 3. 36 plus 3 is 39. Now let's practice A, B, and C. You're going to write down 5 times 2 plus 5 times 3/5. Now gently put the 5 up and a 1 underneath it. 5 times 2 gives you the answer 10. And 5 times 3/5, the 5's cancel out, will be 3. 10 plus 3 is 13. So the answer for that one is 13. Now let's do 12 times 2 plus 12 times a fourth. 12 times 2 plus 12 over 1 times 1/4. 12 times 2, 24. 4 will go into 4 once. 4 goes into 12 3 times. You end up with a 3. 24 plus 3 is 27. The answer to B is 27. Now, in this problem, you're going to take 2 times 3 plus 2 times, that's 6/10, 0.6. Okay, I'm just going to use parentheses to show multiplication. 2 times 3 is 6. 2 times 6/10, 2 times 6 is 12. There's one number behind the decimal point, so you have to have one number in the 12 behind the decimal point, so that's 1.2. 6 plus 1 2/10 gives you the answer of 7 2/10. All right, now let's go on to page 487 and look at example number 3. Fran is making a pair of earrings and a bracelet for 4 friends. Each pair of earrings uses 4 5/10 centimeters of wire, and each bracelet uses 13 centimeters. Write 2 equivalent expressions and then find how much total wire is needed. Well, it says using the distributive property, 4 times 4 5/10 plus 4 times 13 is one of the expressions. The other expression is 4 times 4 5/10 plus 13. You'll get the answer both ways. So the answer will be 70. When you take 4 times 4.5, you get 18. And 4 times 13 will give you 58. 58 plus 18 gives you 70 centimeters of wire. Now let's do letter G together. Each day Martin lifts weights for 10 minutes and runs on the treadmill for 25 minutes. Write 2 equivalent expressions and then find the total minutes that Martin exercises in 7 days. One way is to show 7 times 10 plus 25. That will equal 7 times 10 plus 7 times 25. And when you do this problem, you're going to end up here with 35. 7 times 35, and that's the same thing as 70 plus 175. And I believe the answer that you're going to get for this problem is 245 minutes. So 245 minutes is your answer. Both of these give you 245. Okay? Now, the next thing we're going to do is called factoring. Factoring an expression. And what does that mean? Well, let's look at this. 12 and 8. We want to find the greatest common factor of 12 and 8. Factors are the numbers that you multiply with to get the number. So here, one way of doing it is to do the prime factorization. Prime factorization of 12 is 2 times 2 times 3 gives you 12. 2 times 2 times 2 is 8. You circle the common factors from the prime factorization. They both have a 2. 2 times 2 is 4. So when you want to factor it out, you'll pull a 4. Pull a 4 out. So you say 12 plus 8 equals 4 times 3 plus 4 times 2. Or, if you use the distributive property, 4 times 3 plus 2. So, 12 plus 8 is the same thing as 4 times 3 plus 2. Once again, if you know what the greatest common factor is, you don't have to do the prime factorization. If you know that 4 is the largest number that divides 8 and 12, you don't have to write out the prime factorization. Okay, now let's look at letter H. In letter H, what's the largest number that will divide a 9 and a 21? In that problem, it's going to be 3. Now, 3 times what will give you a 9? Well, 3 times 3 will give you a 9. And 3 times what is 21? 3 times 7. So if you take 3 plus 7 is 10. 10 times 3 is 30. 9 plus 21 is 30. Once again, it's not the answer here. We are learning how to factor. What's the largest number that will divide them both? Okay, let's look at letter I. 14 and 28. What is the largest number that will divide a 14 and a 28? Yes, it's 14. 14 times 1 is 14, and 14 times 2 is 28. So that will factor to 14 times 1 plus 2. Now in letter J, we have to figure out what will divide an 80 and a 56. This one's just a little harder. You could list your prime factorizations, and it's going to come up with an 8. 8 times 10 plus 8 times 7. And that will give you the answer for this problem. Now, let's go on to page 488. Example number 5. In example 5, factor 3x plus 15. Well, 3x equals 3 times x. 15 will equal 3 times 5. You're doing the factorization. What do they both have in them alike? They both have a 3. So it's going to be 3 times x plus 5. 3 times x is 3x. 3 times 5 is 15. All right, so it wants us to factor each of these expressions. So for letter K, 16 plus 4x. I'm going to list my factors for 16 and my factors for 4x. Let's practice this up here. 16 and 4x. 16's prime factorization is 2 times 2 is 4 times 2 is 8 times 2 is 16. Those are all prime numbers. For 4x, that's 2 times 2 is 4 times x. Now we have to identify everything that they have alike. They both have a 2 and they both have another 2. So the factor that can come out is 2 times 2, so that equals a 4. So it's going to be 4 times something plus something. All right, it has to equal 16 and 4x. Well, 4 times 4 is 16, and 4 times x is 4x. So that's how we can go from this problem to this problem. Okay, now let's do the same thing for L. I'm going to circle this so we know that this goes with K. Now we're going to do another circle for L. 7x and 42. 7 is a prime number, so that's just going to be 7 times x. Now, 42's prime factorization. Well, we can do a factor tree. 42 equals 2 times 21. 2 is prime. 21 is 3 times 7. They're both prime. So 2 times 3 times 7. Well, what's the only thing that they have alike? It is a 7. So we're going to pull the 7 out. 7 times something plus something. Well, 7 times what equals 7x? 7 times x. And 7 times what will equal 42? On that one, it's going to be 6. All right, now let's go to m. We'll do m's work above it, the prime factorization. Okay, so for 36x, the prime factorization for 36, do your factor tree. I'm going to start off with 6 times 6 is 36. Neither one of those are prime, so I'm not circling it. What times what is 6? 2, which is prime, times 3. 2 times 3. So for 36, you're going to have 2 times 2 times 3 times 3 times x. This is 36x equals. Now I have to show what 30 is. Let's make a factor tree for 30. 2 times 15. 15 is not prime because 3 times 5. 2 times 3 times 5. What do they both have in alike? They both have 1, 2. They both have 1, 3. So you're going to have 2 times 3 equals 6. 6 is your greatest common factor. So 6 is going to be outside. Now, 6 times what is 36x? 6 times 6x is 36x. 6 times what is 30? 6 times 5 is 30. And that is how you get the answers for letter M. Now, let's go ahead and do the guided practice together before I have you do the homework for tonight. The guided practice. Number 1. Find 9 times 8 times 2/3. Put this on pause, go ahead and do the problem, and then check to see if you have the right answer. All right, nice to have you back. To do this problem, I'm going to take 9 times 8 plus 9 over 1 times 2 over 3. 9 times 8 is 72. 3 will go into 3 once. 3 goes into 9 3 times. 3 times 2 is 6. So 72 plus 6 gives you the answer of 78. Any questions on that? Okay. Let's go on and do 2, 3, and 5. Go ahead and put it on pause. You can do 2, 3, I meant to say 4, not 5, and then check your answers. Welcome back. This is how you do number 2, 3, and 4. In this problem, you're going to have 3x plus 3. And that is the final answer for that one. 3 times x and 3 times 1. All right. For number 3, you're going to have 5 times x is 5x plus 5 times 8 is 40. Does everyone see where the 40 came from? 5 times 8 is 40. All right, in number 4, you're going to have 4x, 4 times x, plus 4 times 6 is 24, using the distributive property. In number 5, what will divide a 25 and a 60? Well, the largest number I can think of is 5. 5 is going to multiply something to give me a 25, and it's going to multiply something else to give me a 60. Well, 5 times 5 is 25, and 5 times 12 is 60. So if you wanted to rewrite this using the distributive property or factoring it, this is what you're going to write. In number 6, what's the largest number that can factor between a 4x and a 40? Well, I know that 4 can divide them both. So 4 times something plus something. All right, well, 4 times x is 4x, and 4 times 10 will give you 40. Now we're ready to do number 7. 6 friends are going to the state fair. The cost of one admission is $9.50, and the cost for one ride on the Ferris wheel is $1.50. Write 2 equivalent expressions and then find the cost. Well, you can say 6 times $9.50 plus $1.50 equals 6 times $9.50 plus 6 times $1.50. Remember, 6 times this and 6 times that. Now, 6 times $9.50, well, actually, let's go ahead and add this one, 10. This will be 6 times 11, that's 66. Let's see what we get here. 6 times 0 is 0, carry a 3. 6 times 9 will give you 54, plus 3 is 57. All right. Now for the next one, 6 times 0 is 0. 6 times 5 is 30. Put down a 0. Carry a 3. 6 times 1 is 6, plus 3 is 9. All right. Now you have, forgot my decimal point, $57 plus $9. They both will equal $66. When you add those two together, you're going to get 66, and 66 equals $66. Now, rate yourself on these problems here, on this problem here, on this scale, and hopefully I have a lot of clear sunny days. Your homework assignment for tonight is going to be to do page 489. On page 489, I would like for you to do 1 to 13. Let's just quickly look at these. Here, you're going to look at example 1. Do these like you would for example 1. In 4 to 6, look at example 2. And don't forget you have to use the distributive property to rewrite them. Number 7, you're going to look at example 3. And then in 8 to 13, refer to examples 4 and 5. You're going to find the greatest common factor in each one of these and then make it look like the distributive property. Have a good day.